Welcome back to the Dargslan series, part 2 of 24, and this is where the map starts taking shape. Today we're charting the local AI landscape, the models, the runtimes, the tools you'll actually be running on Linux heading into 2026. We'll break it down into 5 clean layers, name the key players in each, and explain what every piece actually does. So by the end you've got a working mental model of the ecosystem, not just a list of names. So here's the map itself. Every local AI setup, no matter how simple or elaborate, breaks down into these 5 layers. At the bottom, you've got hardware, then the model weights themselves, then the runtime that actually executes inference, an orchestration layer for proxies and agents, and finally the application you interact with. Once you see this structure, the whole ecosystem stops feeling like alphabet soup. Every tool you'll encounter slots into exactly one of these 5 boxes. Let's zoom into that third layer, the runtime, the engine that actually runs the model. There are 4 serious contenders worth knowing. Llama.cpp is the raw C++ engine underneath much of the ecosystem. VLLM is built for production serving with multi-GPU throughput. LM Studio gives you a polished desktop GUI. But for this series, we're standardizing on Ollama. It wraps llama.cpp behind a clean CLI and REST API, installs in one line, and gets out of your way. Pick it now, and every later part will just work. With the runtime settled, the next question is what you actually feed it. 5 open-weight families dominate the 2026 landscape, and each has its own personality. Llama from Meta is your safe all-rounder with the biggest ecosystem. Mistral is lean and fast. Qwen from Alibaba punches hard on code and multilingual work. Phi is Microsoft's small but mighty contender, and Google's Gemma shines at following instructions. You'll meet all of them as we go, but knowing the lineup now makes everything downstream easier. Now, those models in their raw form are enormous. A full precision Llama 3.18b weighs in at 16 gigabytes. Quantization is how we shrink them to fit real hardware, and the quality loss is far smaller than you'd expect. Q4KM is the default you'll see everywhere, under 5 gigs, with quality that's genuinely hard to fault. If you've got the RAM, Q5KM is the sweet spot. Drop below Q3 only when memory forces your hand. Jumping ahead briefly to retrieval, once you start building RAG pipelines in Part 13, you'll need somewhere to store embeddings. 4 options actually matter. Chroma is the default pick. Embedded, SQLite style, 0 operational overhead, perfect while you're prototyping. Qwen is where you graduate when you need real production scale. PG Vector makes sense if Postgres is already in your stack, and FOSS isn't really a database at all. It's a library you drop into scripts when you just need fast similarity search. Now, a model running on its own is really just an API endpoint, useful but not exactly inviting. The front end is what turns that into something that feels like ChatGPT. Open WebUI is our default for the series, a polished multi-user interface with RAG built in, and we'll set it up properly in Part 16. Anything LLM is the RAG-first alternative if documents are your main use case. Continue brings local models into VS Code as a Copilot replacement, and for scripting, a custom CLI with curl and JQ is often all you need. Once you've got a model and a front end, the next question is how to wire real logic between them, and that's orchestration. LangChain is the Swiss Army framework for chaining models with retrieval, tools, and memory, while Llama Index narrows in on document-heavy RAG. Light LLM is a quietly essential proxy that makes any local model speak the OpenAI API, so existing code just works. N8N gives you visual workflows where AI is one node among many, and LangGraph steps up when you need proper state machines for agents. So here's how all those pieces actually stack up in practice. At the bottom, you've got Linux, GPU drivers, and Docker, the foundation everything runs on. Llama 3.18b served by Ollama gives you the model and its runtime. Chroma stores your embeddings, LangChain handles the retrieve, augment, generate dance, and Open WebUI is what the user actually talks to. 5 layers, cleanly separated, And by part 22, this is the Ask My Doc system you'll have running on your own machine. And those are the specific picks for this series. Ollama for the runtime because it installs in one line and ships with a REST API. Llama 3.18b as the default model, or 3.23b if you're on CPU only and still want something genuinely useful. Chroma for vectors since it embeds right into your Python. Open WebUI for the front end, and LangChain for orchestration because the examples are everywhere. Pick one, learn it well. You can always swap later. Now, a quick honesty check. There are a few big areas this series deliberately leaves alone. Training and fine-tuning is a different rabbit hole entirely, needing PyTorch fluency and serious GPU budget. We touch it briefly in part 23. Diffusion and image generation is its own universe. Part 18 dips a toe in, but stable diffusion really deserves its own series. Multi-node serving with VLLM and Kubernetes is production-scale territory, overkill for individual builders. And training a model from scratch? Months of compute, not happening here. With that scope set, let's talk about pace, because local AI moves at 3 very different speeds. New model releases, quantization formats, benchmark leaderboards, those churn weekly, and chasing everyone will burn you out. Runtimes, frontends, frameworks like LangChain shift on a scale of months, so it's worth checking in periodically. But the foundations, Linux, Docker, REST, JSON, the core idea of RAG, those are stable for years. Invest your learning time accordingly. So where do you actually get your news? Pick 2 or 3 of these, no more. Chasing all of them is how the burnout starts. Our local Ollama is the pulse of the community, daily and unfiltered. Hugging Face trending shows you what people are actually downloading. The Ollama library page tells you what's landed in the runtime you'll be running. Simon Willison's blog is the thoughtful weekly digest. Latent space goes deep on the builder side, and Hacker News with an AI filter catches the rest. Often the comments are where the real context lives. Let's pull it all together. 5 things to carry out of part 2. Every local AI stack has the same 5 layers, so pick one tool per layer and learn it deeply. Ollama, Llama 3.1, Chroma, Open WebUI, and LangChain are our defaults. Trust Q4KM quantization because it's the sweet spot between quality and memory. Remember that models churn weekly, but the architecture doesn't, so master the structure once. And keep your news diet small. 2 sources really is enough. Before we wrap, here's a cheat sheet worth bookmarking. As we move through parts 5 to 15, names like Qwen, Phi, Qdrant, and LiteLLM will keep showing up, and it's easy to lose track of which is a model, which is a runtime, and which is glue. So when something confuses you, jump back here. One glance tells you what each name actually does and where it sits in the 5-layer stack. And that brings us to the end of part 2. Up next, hardware reality check, where we get honest about what your machine can actually run. CPU-only setups, consumer GPUs, the Mac M series, real numbers, real trade-offs, no marketing fluff. 2 down, 22 to go. See you in part 3.